So this meter here, which was functional, if I turn it on, you can see the backlight is now the only thing that comes on. This meter was taking 13,000 volt hits without a problem, and the AC and DC voltage modes were still functional just fine. So when I modded this generator last night, I thought I'd use this as a guinea pig, and it's definitely damaged that unit beyond use now. I'm just going to turn off our LaCroix scope here, cut the noise down a little bit, and you can hear what this kind of sounds like. Again, with the AGC it's probably pretty difficult, but I can tell you from here that's quite a bit louder, and you can hear this meter doing some major breakdown on the inside. So yeah, that switch location is still the same thing that's saving it. Well, that's the end of this meter. I don't think we're going to do anything more with it. It's definitely damaged beyond use now. Main control IC's dead. Backlight's the only thing that works. Batteries are good. So that'll go to the recycle bin. I thought what you'd do is run 5kW's Fluke 107 and just see if this meter will survive this transient. If it doesn't, I'm not going to run the Fluke 101 across this. I'm going to keep that meter just as a baseline for future testing. I was planning on originally doing that with this meter, but yeah, I think 5kW would like to see this thing damaged. So let's just give this a swing. If this doesn't work, I'm going to increase the voltage of the generator. So my goal today is to damage this meter, if that's not clear yet. So let me just go ahead and hook this thing up. You know, some time ago I posted some videos about making this high voltage probe. Yeah, I've been very impressed with this thing. I've used this probe throughout this testing. The bandwidth on this is just incredible, and I have absolutely no concerns about running this thing at these voltages. You know, I tested this thing, it didn't break down until about 65,000 volts. It's a pretty good piece of hardware for homemade. Okay, so I've modified the generator. The peak voltage is now 14,000 volts. So we'll see if 5kW's Fluke 107 will handle this. Looks like it again went through some kind of a reset, but appears to have recovered. Guess I'm not sure what that means. Looks like it went into a power save. Seems to be fine. So burst the polarity. Yeah, I'm not so sure that the meter's even working right now. Well, it looks okay. We'll continue on with the testing here. We need to put some new batteries in. So I'm not sure what the problem is. The batteries are not going bad in the meter. For some reason it's being affected by this transient test where it thinks it's got a low battery and it'll shut down. I don't understand why, but it seems to be the problem, so we'll just continue with the test. Okay, that's it. We'll try the functional test. Okay, I went ahead and functional tested the 107. Again, every mode appears fine. So, I've increased the voltage on this to 15,000 volts. Things are getting scary. I also changed out the batteries in the meter just in case. I'm not sure so I just put a brand new set in there. We'll see if that does anything or not. You can see the display on this, how dim this is. It's like in a reset mode right now. Let's power cycle it and see if it comes back. Looks like it does. Ooh, nice. Heard that. I think we're getting somewhere now. Let's do one in capacitance mode here. I don't think we're going to give her the full 5 hits. I think it's on the verge here. Yeah, let's just go ahead and functional test this thing. See if it passes. If it does, I'm just going to go ahead and take this up farther. I'm putting out a 10 volt signal right now. You can see the meter is reading 8.63. I'm going to change this to a volt. 8.61. So generator again, it's set for 10 volts. Should be 7.14 roughly. And it's reading 6.19. Let's see in millivolts range. Just change this to 100 millivolts. Yep, reading low. So yeah, we've definitely damaged it. So we're in ohms mode right now, and I've got the inputs open, and we can see it's reading 0 ohms. Yep, seeing a dead short with nothing attached. Diode mode reading low now. Let's try it in capacitance. Yep, so capacitance mode no longer works. I think we can do better. So again, that's a 15,000 volt transient. Definitely is where the damage occurred. I didn't run full 5 transients. This was I just kind of hodgepodge. I started out at 5 transients, but I noticed that the meter started behaving a little strangely. So I just hit it with 1 transient on the capacitance and a couple of ohms, and yeah, it's definitely been damaged. But I think we can maybe increase the voltage even further and get this thing to really pop. So the Fluke 107's been damaged at roughly 15 kV. Well, it did sound like it broke over. It was never severe like some of the other meters that I've damaged. So I've made one last modification to the old transient generator. I've again increased the voltage. So here we're looking at 5,000 volts per division. You can see we're a little over 20,000 volts, and it's 50 microseconds per division, or a full width half height of roughly 50 microseconds. Okay, let's see if we can finish this Fluke 107 off. Again, it's just got an offset in the two voltage ranges. Ohms, diode, continuity check does not work. Capacitance mode does not work. Let's get some of this out of the way here. Okay, here we go. Yeah, I heard that. Let's give it another hit. Oh, there was a good one. Ooh. Backlight just turned on. Oh, came back. Again, this is two brand new fresh batteries in there right now. You can see the low battery indicator. See the low battery indicator again. Uh-oh. Okay, let's retest it on the voltage scales, see if anything's changed. Okay, the millivolt AC still reads about the same. It's definitely off. Let's try the AC volts mode. Huh. Well, yep, I think we permanently damaged it here. That's a volt. Let's try 10. Yep, totally dead. Yeah, boy, that is definitely out. Alright, let's try DC volts. So I'm putting out a 1 volt signal right now. Completely dead. And we'll change that to 10. Yep, nothing. Still a dead short. Yep. Yep. So the only mode that works now is the millivolt range. Impressive. Something still works with it. This is looking inside the Fluke 107. It would appear, well, it's kind of difficult to tell, that maybe there's been a breakdown of the PTC here. You can see the damage. See the left of the PTC? Yeah, definitely did some damage to it. I think I'm just going to have to trace this thing out and maybe we can see what's wrong with it. So I'm looking at the meter. I'm going to go ahead and lift that and have a look at it. But the damage to the board's pretty extensive. You know, you can see the burn areas up near the PTC here. It's been arcing across some of the switch contacts. And you can see some erosion up in this area here. So yeah, this thing definitely broke down, but again, we heard that during the transients. So yeah, let's just go ahead and pull that one diode out and we'll have a look. Shit, bullshit, mumbo jumbo crap. Alright, what do we got here? Okay, we're gonna go ahead and put in a couple of new diodes here. Also cleaned up some of the other areas that were damaged. And unfortunately, where it's arced over here, there's not much we can do for this switch area. Yeah. Cleaned up around the switch a little bit. Touched up that back joint. I believe that CR13 here is the primary culprit. It's kind of tough now with these all being lead free. Yeah, my heat gun, it really doesn't get hot enough to reflow some of these different solders, so making it difficult as far as repairs. Helps out the landfill though, I'm sure, because I'm sure there's nothing else in these that are carcinogens. Alright, let's check this out now. We'll see. Yeah, it's hard to say if that's all that's wrong with it. I think we'll just have to put it back together and we'll give it a try. Yeah, it appears to be the problem. I've got it in, I kind of quasi-reassembled it here, and you can see it in ohms mode. And it's now reading open. Yeah, I would guess that it was probably CR13 that was bad. Let's just go ahead and we'll put this thing all the way back together and see if it works. Okay, the continuity test works. Diode check seems to work now. Just put a diode in there, be sure. Looks good. Try capacitance mode. Okay, so it's a 0.1 microfarad. Looks good. And a 1 nanofarad. Looks good. Try it in resistance mode. Notice it reads an open now. We'll try it at 10 meg. Pretty good. 1 meg. Looks good. 100K. Looks good. 10K. Looks good. 1K. Looks good. 100 ohm. Looks good. DOM looks good. An ohm, good. 0.5 ohm, yeah, it's off. 0 ohms, it gets it. It's pretty funny. It's trying. 0.6 ohms for a 0.5. Guess it's okay. Alright, let's try it in the voltage modes. Okay, so I've got it attached to the Fluke. I got the Fluke attached to the Fluke. You can see we're on the 10 volt scale. And we're getting 10 volts out. Looks good. Tried it a volt. Yep, that looks fine. Let's just try it in AC mode. So again, 10 volts. Should be like 7.14. It's pretty good. Let's try it in the millivolt range. It should be like 0.71. Pretty good. And now we'll try it in looks pretty good. Yeah, it seems fine. I'm saying CR13 is really the only problem that was wrong with it. Dead shorted that one diode. Other than that, the meter appears to be fine. Other than the damage around the switch, you can see where it arced, and the damage around the PTC. Again, not a whole lot I can do to repair that area. If we increase the voltage, those areas would probably become even more severely damaged. But yeah, it's pretty good. 15 kV took it out, but 20 kV didn't really cause that much more damage. Go figure. Pretty good meter.